Okay, so just a little more background on where the cast rule comes from. It's not just, because my calculator tells me so. There are reasonings behind it. So let's say we have a point, P, and that the coordinates of P are A, B. So whatever it is, it doesn't matter what A and B are. But we land in the first quadrant because A is positive and B is positive. So X is positive, Y is positive, right? So if that's the point, the distance that we create vertically is the Y coordinate, or B. The horizontal distance would be X coordinate, or in this case, A. We create a right angle triangle, and the hypotenuse that's created here, we call it R because it's the radius of the circle. So if we rotated this arrow around, we call it the primary arm or principal arm, I can't remember now. If we rotate it around, create a circle, right? So this isn't the hypotenuse, it's the radius. So in the first quadrant, the sine of some angle is opposite over hypotenuse, or B over R. But as you can see in the second quadrant, because this distance there would be negative, or negative values of X. Now, that's negative A, so negative A. But even if I find the sine of 180 minus theta, or something in the second quadrant, B and R are still positive numbers. So sine of theta, some angle in the first quadrant, is going to be equal to the sine of 180 minus that angle. So you could put any angle you want in there as long as theta is in the first quadrant. So anything between 0 and 90. So if I put 89 here and 89 there, I would get the same ratio. If I put 80 here and 80 here, it's like saying the sine of 80 would be equal to the sine of 100. You type in your calculator, you see that that's true. Okay, so sine is positive in both the first quadrant and the second quadrant. Now let's look at cos. So the cos of theta, adjacent over hypotenuse, would be A over R. That's in the first quadrant. But now when we move to the second quadrant, it's a negative A, because we're in the second quadrant, so the X value is negative. So it would be negative A over R. So they're not equal to each other anymore. Only sine has that. First and second quadrant are equal to each other. Now, if we chose a cos value in the second and the fourth quadrant, then we'd see that they're equal. And that's also coming up in other lessons. So in this case, they're not equal to each other, but we could say that the negative of cos theta would be equal to the cos of 180 minus theta. So as an example, if you put in 45 degrees here, you type in cos of 45 and you get a positive number. Like this would be positive. But then we multiply by negative to make it a negative number. So then in the second quadrant, this was 45. That means 180 minus 45 is 135. And if you did the cos of 135, you're going to get a negative ratio. So they would be equal as long as you make sure you're multiplying by negative. So I'm going to leave it there and make more videos. Try to keep them shorter.